Let us discuss the concept of impulse. So what is the definition of impulse? It says it is defined as the product of average force during the impact and the time for which the impact lasts. So I'll give a simple example to help you understand this. So I'll take a wooden block. I want to insert a nail into the wooden block. So what do? I take a hammer and hit the nail using the hammer. Now we need to understand a point here. The force of impact, the time of force of impact of the hammer onto the nail is very small, and the same way the force varies as I hit the nail while inserting it into the block. So we need to understand the point here. First thing is that the time of impact is small. It would be like some milliseconds. In the same way, the force also varies during the impact. So this is the two conditions we need to know. I want to insert a nail into a wooden block. I use a hammer to hit the nail. So you can see the time of impact is very small and the force also varies during the impact. So what does it say? Impulse is defined as the product of average force during the impact and the time for which the impact lasts. Now why am I taking average force? I'll get into that. It's very difficult to calculate the variation of force during the time of impact. So what do? We take the average force into consideration, and the equation turns out to be I impulse is equal to F average into the time of impact. Now how do we derive this equation? It's very simple. I will derive it using the Newton's second law of motion. Let's do that. According to Newton's second laws of motion, what it says? Newton's second law says that F is directly proportional to dp bar by dt. This is variation in momentum. So if I rearrange this equation, I can write it as F bar dt is equal to dp bar. Now let's integrate for the time of impact. So integrate for the time of impact, that the momentum also varies. It can be written as dt is equal to p1 bar, p2 bar. What is p1 bar? It is the initial momentum, and p2 bar is the final momentum due to the force that is applied from 0 to t, dp bar. So this can be further written as 0 to t f bar dt is equal to p bar. So this can be written as 0 to t f bar dt is equal to p2 minus p1. That is change in momentum. Now I have taken the force inside the integration. Now if I take average force into consideration, why am I taking average force into consideration? Because it's very difficult to calculate the change in force during the time of impact. Okay, so if I take force, average force, it becomes average force is constant. So when constant, you can take it outside. So this turns out to be, this final equation becomes F average is equal to T 0 to T T2 minus T1, and the final equation is F average is equal to T2 minus T1. And what is this? This is impulse, that is I is equal to F average T is equal to P2 minus P1. So the note I have written, it is also equal to the total change in momentum produced during the impact. So what does impulse says? Impulse is the product of average force during the impact and the time for which the impact lasts. So you can see, to give an example, you might have watched cricket players catching a ball. So when they catch the ball, they pull the hands downwards. Why do they do that? Because let's take the ball is coming at a velocity of 10 meters per second. Okay, so hits. So what is the purpose of catching a ball? They want to reduce the velocity to 0. When they are reducing the velocity to 0, the momentum also changes. So see, ball is having, let's say ball is like 100 grams and it's coming and it is hitting the hands, like I'm going to catch it. So this 100 grams ball, it comes and I'm catching it. So what do you see? You can clearly see the 100 grams ball is traveling at a velocity of 10 meters per second. I'm trying to stop it. I'm trying to catch it. Okay. I'm trying to catch it. What happens to the velocity when I catch it? It becomes 0. But why do they pull it? Why do they pull the hands? Because they are giving more time to the ball to come to rest. I repeat, why they are pulling down their hands? They want more time for the ball to come to rest. When the ball takes more time, what happens? You can see the formula. When the time is more, what happens? The force, the impact, the force reduces. When the time is more, the change in time, the time is more, what happens? The force reduces. The force of impact reduces. So that if they pull down, they will not hurt their hands. So this is the concept of impulse. When I'm catching the ball, what do? I pull it downwards. Why do I pull it downwards? Because I'm giving sufficient time for the ball to come to rest. Why am I giving sufficient time for the ball to come to rest? Because it reduces damage to my hands. Because if I hold the ball, if the ball comes and if I hold at this position, what happens without pulling it down? Because the ball is coming to rest at a very less amount of time, and the force experience. When this is less, what happens? The force of impact would be high. Okay, are you getting the point? Now let's see. I'll give a problem. I'll solve a problem to help you understand this concept. Let's solve the problem. So let's calculate the problem. Calculate the impulse necessary to stop a 2000 kg car traveling at 72 kilometers per hour. So what is the mass? Mass is 2000 kg. What is the final velocity? See, I'm trying to stop. I'm going to stop. So it is 0 meters per second. What is the initial velocity? What is the speed with which the car is traveling? It is 72 kilometers per hour. So let me write this. So the initial velocity is 72 kilometers per hour. Let me convert this into meters per second. How do I do that? 72 into 1000 meters by 60 minutes into 60 seconds. So how do I take this? This gets cancelled out. 72 into 10 by 36. Cancel. What happens? 5. This is 18. You divide by 2. You get that. 72 into 5 by 18. This gets cancelled. 4 is equal to 20 meters per second. So what is the impulse? How do you calculate? Impulse necessary is, what is the formula? Impulse is equal to F into T is equal to P2 minus P1. Or you can write it as P2 minus P1. P2 is the final momentum and P1 is initial momentum. You can write this as MV minus MU. What is M? 2000 into, what is V? V is final velocity and U is minus 20. This turns out to be minus 40,000 Newton second. Why do I take this minus? Minus gives the retardation effect. So you can see impulse is stopping it. Check, the car is coming to the halt. What happens? There is an impulse coming to the picture. There is force acting. For what is retardation force acting on the car for a certain amount of time? What happens? The car comes to rest. This is a basic concept of impulse. Let's go to the next concept.